This is our first webinar, or maybe we can call it a podcast, on leveraging AI in subsurface studies. Here, we want to discuss more about geophysics, geology, and any kind of subsurface domain. We'll be bringing experts such as Shubham, whom we have our first guest today, who'll be talking about their research, and then we'll try to discuss more on how to improve the technologies that are used in the Earth's research today, and then how you can leverage new technologies. It will be more on a fun conversation, not too serious conversation. It doesn't have too much of equations and formula to go about, but still we'll try to learn from each other and hope it helps the entire geophysics community as a whole. So let me introduce also Vishal. So Vishal is also is a geophysicist who has done his master's from University of British Columbia in Vancouver. And as for myself goes, I am a geophysicist who have done my PhD from University of Calgary. And we are both here to listen from our experts and also talk about how AI can help the new domain as a new technology, how it can help. So without further ado, let me introduce Shubham. So Shubham is our first guest today, and he is presently a PhD candidate at IIT Roorkee. He has also completed his master's from ISM Dhanbad, and he is really passionate about learning the subsurface structure of Earth, and his methods are through seismology. So let's start maybe asking few questions to Shubham and what is his research about, what is his overall view about new technologies, and also maybe carbon capture and carbon sequestering and so on. So Shubham, can you briefly describe your research a little bit?
Thank you.
Maybe I
Uh,
can pull the slides that you have given us. So
yes, you can. You can.
sure.
And thank you for having me here on your podcast and your first guest.
No problem. So I can see you are working on MT, that is magnetic telluric, right? So can you
No, no, no.
talk a
It's
little
it's
bit?
a it's a anti
Can
it's a moment tensor inversion.
Oh, moment enter inversion. Okay, good. So can you talk a little bit about what you are doing in your PhD or your thesis,
Okay,
maybe?
okay. So like I have done my masters from ISM Dhanbad, Indian School of Mines Dhanbad. So here from there I started my work on moment tensor inversion, which is useful to find out the source mechanism of earthquake. Like earthquake happened in all regions in India, all over the world. So finding out the source mechanism, like on which fault plane, which earthquake has happened, what is the cause of those earthquake. So we can determine by the mathematical method, which is called moment tensor inversion. And the technique which I used in this PhD also is isola. It's a technique which is developed by two people from Czech Republic. So it's a isolated expertise which will isolate the earthquake event and find out the source mechanism and the focal mechanism of those earthquake events. So these are the general picture of these events. So
So
yeah,
for our audience, Shivam, can you tell us a little bit what is source mechanism really? Like how is it related to earthquake?
okay. So like that when an earthquake happened, so it happened over a fault or a rupture. So when a fault just slip down or just a breakdown happened, so there's a enormous amount of energy just released from there. So understanding those the source reason from where the energy released, so it is we can find out by the source mechanism of those earthquake events. So generally, this is the main purpose of doing finding out the anti inversion.
Mm-hmm. Okay, cool. And what does your you have a synthetic seismogram? Can you briefly tell us about what is synthetic seismogram? Why you are using it, basically?
Okay, so like in my case, what I'm doing is so we like we have a we will do the same finding out the source mechanism by having a synthetic seismogram. Like we will record the seismogram in the field stations, like we deploy stations in various locations and record the seismograms, earthquake events. So by creating a synthetic seismogram, by knowing that the earthquake magnitude, the location of the earthquake event, and other properties like the velocity model, like event is happened somewhere and we record it at somewhere else. So like it will propagate somewhere, so it have effect of those property also. So we will generate a synthetic seismogram by the medium property, by the source property, and then we will correlate with the actual seismogram which we will record, the observed seismogram, and minimize that those seismograms to find out the exact culture,
Uh-huh.
source mechanism. Okay, so we will just find
Okay.
out, okay, this is the source mechanism of this event. So this is the
Okay.
basic principle of finding out the anti-inversion.
Okay. I see. Magnetic moment tensor inversion, right? Okay. Uh,
Correct.
that's a difficult subject. So maybe I see you have results and interpretation. So let's discuss what is I know. So then synthetic seismogram is your data, right? So and it's a quite a complex data, right? So how you what is your like yeah, maybe you just can discuss about the results and
Yes, yes.
interpretations. Yeah.
Correct, correct, correct. Like I told you already that we have observed seismogram. We will create a synthetic seismogram by the velocity model, the properties of the medium, and the source property which we know, like the magnitude we know, the depth we know. So we will create a synthetic seismogram, and then we will like do the dual error minimization by the
Mm-hmm.
least square inversion. Okay, so by that we will find the synthetic seismogram which will best fit the source mechanism. Okay, so
Mm-hmm.
we don't know the exact location of the earthquake event. So what we will do, we will just create a trial source position at certain depth. Like let's say like there's an event happened at a 10 kilometer depth. Okay, so we don't know the exact depth of that event. It's a like a general, it's a vague result. Okay, so what we'll do, we will
Mm-hmm.
just put a trial source position, from depth of 5 kilometer to 15 kilometer. Okay, 5 kilometer, 6 kilometer,
Mm-hmm.
7 we put the trial source position and the magnitude also. So we will just find out the location where we get the maximum correlation with the observed seismogram. And there are other
Mm-hmm.
properties also through which, so like here you can see in the picture of the focal mechanism, the beach ball location. So you can see that I think the fourth one will represent the highest correlation in that. So
Okay.
we can just finalize that. Okay, means this is one way to find out that okay, this is the best mechanism. This
Mm-hmm.
result is showing the best mechanism. Along with that, there are certain other parameters which will tell you that whether this result is actually correct or not. There are various
Okay.
uncertainties in that result. So there are certain
Mm-hmm.
parameters in that, like we have variance rejection factor, we have condition number of that those eigenvalue which we will find out. So those things and the correlation is there, and the double couple percentage. Like we know all know that the earthquake event mainly happened. Like if we just separate out the volcanic event, the nuclear event, then all other
So
event happened
volcanic and nuclear event are quite different from the earthquake events, right?
quite different from the general earthquake which happened on the fault. They have a
Okay.
different pattern.
Okay.
They have a different pattern.
Mm-hmm.
So mainly the
Okay.
events happen over a fault region. So we know that
Mm-hmm.
they are and mathematically, if we have to say that whether it's a event happened on a fault or not. So we can discuss it with the double couple mechanism. Like we have
Okay.
generally so all geophysics people know about this during our seismology classes. Like we can discuss it with
Okay.
the double couple mechanism. So we can find out
Okay.
that it is a correct event or not by double couple percentage and double couple percentage of these events. So these are certain
Mm-hmm.
parameters from which we can find out, okay, this event is a correct event, this result is correct result or not. Other than that, in the below figure, we can see that we have matched the observed
Mm-hmm.
and the synthetic seismogram. So if the initial wavelengths are matching, so we can conclude that okay, these results are matching properly. So there are certain parameters, and we are finding all these properties like we have mentioned the table, like seismic movement, the strike, dip, and break of those fault plane, like the property, the
These
actual
ones
fault.
over here, you mean? Okay.
Yeah,
Mm-hmm.
the table, the seismic movement, the strike, dip, and
Okay.
break of those
I
fault
see.
plane,
Uh-huh.
the stress drop, the focal depth of the actual event, and the azimuth and plunge of the P and T axes. P and T axes are representing the proper the tangential the pressure axis and the tangential axis, like the energy spread of the event. This will
Mm-hmm.
represent properly those things. So these are generally a general in a general these are the things which I do in my work.
Okay. Mm-hmm. Okay. Great. And what challenges are you right now really? This is a very interesting research. What are your challenges right now?
Okay, so like finding out the in earthquake source mechanism, the challenges that we don't have deployed stations all over the region. We have like very widespread uh, stations deployed. So like if the event happened in the means in very far region,
Very
like we
far
can
away location. Yeah. Mm-hmm.
like we can say those things are telescopic event. Like those happen in more than 1,000 kilometers away or 10,000 kilometers away. So we cannot exactly find out the source mechanism, source character of this event in the web form. So we need the proper deployment of station in the near region, local region, or the like normal region, nearest region. So we this is the main problem. Like that there are various locations where we don't have a proper station. So we will just record from somewhere a far side region and find out the focal mechanism. So they are still uncertain results. So
Yeah.
these are the main and understand
Uncertainty. Yeah.
and we don't also don't know the proper medium and property of those the earth structure in the crustal region at all places. So that is also a difficult task to finding out the exact focal mechanism and the source mechanism of those earthquake events.
Hmm. Okay. Sounds good. So your main technology here is moment tensor, right? Finding the moment tensors, right, through all these
Correct.
earthquake locations. Okay, so maybe since the topic of this podcast is also focusing on new techniques such as machine learning, deep learning, do you think you can also, I mean, one of the things that deep learning can solve is you can have less data but a good model that can fit your data. In that way, you might not have to generate too much of synthetic seismograms, right?
Correct.
So, do you think is there research around also taking new approaches like this in
Mhm.
this domain?
So, like you mentioned that deep learning and the machine learning models. So yeah, people are using it, and I'm also like looking for those papers and looking for those like, proper articles and research papers. So like people are using those deep learning models. Like we have a complex event. Like it's not a single rupturing. We have several rupturing happen for a particular event also. So finding those complex earthquake event, those are complex rupturing where we have so many parties in a single event. So these complex event can be properly distinguished and understand by the models of deep learning and machine learning models. So people are using it. Apart from that, I know that cluster modeling is also not vaguely known to all of us in those regions. Some in some regions. So for that
Mm-hmm.
cases also these models are very useful and people are using it. I've seen the various papers. Also that I've seen that there are several events like we have deployed this station which is very noisy. So like we cannot finally find out the proper character of the earthquake event. Like it is not able to distinguish from the noise level of those events. So in those cases, those machine learning model and deep learning model are very useful. It came useful. I've seen various results where people are using those things. So I think people are using, and it's a demand of a situation. We have various enormous amount of data. So for those data, we can find out a proper understanding of the structure and the structure of the earth and source mechanism. Maybe I think so too. So in those cases,
Mm-hmm.
they are using.
Oh, okay. Yeah, good to know about that. Yeah. Then you definitely kind of support that this kind of would be a very good problem for, yeah, that can be solved with
Correct,
yeah,
correct.
yeah. Good, good. So so how do you think is your research have a broader impact on the conventional energy? If you go into maybe a business case kind of now, and think how is it impacting, or maybe getting more oil, more, or maybe looking into unconventional reservoirs or things like that? How is it impacting?
I'm still thinking of that. Like, how can we market our result or our Earth source mechanism or anything which I'm doing in energy point of view or an oil and gas exploration industries. So like
Mm-hmm.
I know that people are using basic seismology method for finding out that like it's a natural source of the natural earth event. So we can also find out the structure of the earth. Earth means crust also, where we have reservoir also. So we can use we will still utilize those these earthquake event and these recordings
Yeah.
in finding out the reservoir character. Other than that, I have seen that in the reservoir where we have reservoir of oil and gas now. So we have a reservoir induced seismicity, which happened like if you just explore oil and gas from those regions, which when you produce oil and gas, so the reservoir also get some pressure, and because of that, they induce some seismicity. There's some certain events happen in those regions. So to understand the pattern of those certain earthquake event, why this happening, what is the cause, and what will it affect in those oil and gas. Because when we are exploring oil from some certain well, so if a large earthquake happen there, it will impact very harshly to the market
Mm.
economically and life also because people are working there. So for those reasons, I'm just like regularly monitoring those earthquake events and finding out the reason of that and whether it impact the, the location or not. So I think in those reasons, people are using the source mechanism in the earthquake seismology.
Mm. Okay. Yeah. That sounds interesting. Okay. So maybe let's come to a more broader view now. So what is your so it's a very controversial topic, right? We're still studying conventional energy, but then how is it going into clean tech or climate change, right? So I mean, what is your view, right? How do you defend that it's like conventional energies do will are not really that bad. They are not.
Okay,
Mhm.
okay, so from the conventional to means conventional technology. Hmm, can you repeat the question? I just somewhere went somewhere else.
No, so the question is mostly like so because we are in conventional energy, right? And it has a high carbon footprint and things like that, right? So that's being now it's termed as a bad form of energy, right? Kind of. So it's not good for the environment. It's not clean energy, right? So what do you think about, what's your opinion on that? Like how do you agree with it, or do you not, or how do you
Okay.
defend the statement?
So okay, so conventional form of energy is still like the oil and gas mainly. Mainly, this is the main breathing part. So this is where still we have to use it. We cannot just deny it that we cannot. We have to just directly convert from non-renewable to renewable form of energies and the the clean energy form. So we have to still continue with this part along with that because of climate action and greenhouse gases. Because of climate actions, so we have to just little bit modify towards the renewable part of energy. Like people are using, in India we
Mm-hmm.
are using the solar part energy. In West, people are using the geothermal energy very much. We are moving towards that. So I think slowly just we slowly just moving towards utilizing both of them, na? Like
Yeah,
conventional and the non-conventional also. So that will be the best part of best part of these things.
best of
Like
the
we can
two worlds, right? Yeah. Mm-hmm.
correct.
That's good. Yeah. And because you also have carbon storage, like carbon capturing happening a lot, like decarbonizations, right? So yes, and definitely. So, do you have any experience on that, like decarbonization or things, research were happening in your university? Do you know something about it?
So like I heard like I regularly go through the articles and the post and all those things. People are working also in CCS carbon capture and discussion. So it's a good method of how to how to manage all those carbon and climate action which is happening, reducing the greenhouse gases, just storing the all those carbon footprint to the geological body inside, and it's a requirement of current situation. Like governments are making plans for that, so we have, like oil and gas industry have to follow those rules, and like markets also changing towards renewable energy. So this is the I
Mm,
think this is currently the best way to control all those impact and to all those climate impacts over our industries, means oil and gas industry. So I think this is the best
mm-hmm.
way that we have right now.
Cool, cool. No, that's really nice to find know about those insights. Yeah, that's I mean it's a very big topic right now happening. So yeah, I think we really had a good 20 minutes chat. And I think people have learned a lot about moment tensor, right? It had a lot of equations, but it was a really interesting research, Shubham.
Thank
And definitely, please check out our EarthScan LinkedIn profile and also our EarthScan page where we will post this. We'll post the podcast. And if you have questions, you can also reach out to Shubham. We'll post his email address. If you reach out to us, we'll share his email address, and he can talk about his research also in more details there. Well, thanks, Shubham, and for having you in this first podcast. And it's a nice one, a nice way to break the ice and talk about a lot of interesting stuff. So, thank you all. Okay, bye.
Okay. Thank you for having me here. Thank you, Vishal. Thank you, Tanisha.
Thank you, Shubham. Take
Thank
care. Bye.
you. Bye.
Bye.
Okay.
Let's just leave.
Yeah.